Yeah, I gave you guys the mock test, right? I went through whatever you have written in the mock test. Many of you, what you've done is the main mistake that you've done is in Prim's algorithm. Basically, you've taken the graph, you've tried to solve it directly. Please don't do it. If you're asked to solve using Prim's algorithm, follow the table method. Okay, this kind of three column method. And in the illustration part, you can do the diagram. Over here, you will be writing the remaining vertices and here the vertex that you are selecting. If you remember very clearly, Prim's algorithm is not a topic which I taught you after the lockdown period. It was taught to you in the classroom before the lockdown period. The moment I gave you guys Prim's algorithm, people have basically written similar to Kruskal's method, which I taught you in the lockdown period. Please don't do that. The way in which you solve Kruskal and the way in which you solve Prims are different. Okay, the way in which you have to write also is different. So don't write all the edges over here and try to tell which you are going to select. That is not the way to do for Prim's algorithm. So if you want to know, you can refer to page number 295 of your Ananya Levitin textbook. They've clearly given to you the method for solving for this particular thing. Also, if you have taken down the notes when I taught in classroom, you can refer to that as well, wherein I have taught you with this kind of three column method. This particular three column method is what you call as concept tracing. You need to know the concept tracing for each and every problem uh, that I am actually teaching you. Okay. So whichever lab programs are there, concept tracing is a must for you to know for those lab programs as well, because every lab program is based on how you do your concept tracing. So this is about your Prim's algorithm, wherein here you will be writing all the remaining uh, remaining vertices with if they are directly connected to the edge or not. So here it will be B to A. Okay, so A comma 3 will be there as it is. C is not directly connected to A, so it will be minus comma infinity. Then F is connected to so A, this will remain the same. The first row will remain the same. But the second row, I've just taken your Dijkstra's algorithm and I've put it here. So don't follow this. You can't have this adding and all. Okay. Instead, directly you will be putting uh, B comma 1 over here. Okay. C is B comma 1, meaning B is already selected. So B is also part of your tree vertices. So you basically can select C as well with a value of 1. So it will be B comma 1 over here and goes on. So if you refer to page number 295, you can clearly see the working of it. Okay, so this is about your Prim's algorithm, which I really found people doing lots of mistakes. The second one is about your knapsack problem. I haven't given to you greedy method. Okay, I had given long back, I guess. So greedy method, follow this tabular column method. If you have to solve knapsack using greedy method, follow this tabular column method. And if you have to solve knapsack using dynamic programming, then you have to follow the matrix method which I had taught you. So that being said, this particular this one sheet solutions for assignments, everything I've added in the classroom app. Okay, so you guys can basically refer to it. This I have added the PPT, I'm sorry, the links to all the various videos that we've done. Everything I have added in the classroom app for your reference. When came to time complexity, I clearly mentioned you to do divide and conquer, you to explain divide and conquer recurrence relation. So this divide and conquer recurrence relation, how did you get it? That you need to explain with an I mean with the figure. After you explain that, I told you to state the master's theorem. So you need to state the master's theorem completely, and then you can take an example problem and you can solve and explain how exactly master's theorem is used for solving. So that was what was expected from the second question that was given to you. Coming to the third question, that is job scheduling. Again, here many of you have not done it completely according to the steps that are required. I've given you guys the assignment, right? Uh, Over here in this particular problem, when you are given, first step that you have to do is sorting it in the descending order of the profit. Once you sort it in the descending order of the profit, then you will have to do this way of taking down the deadline, highest deadline, having that many boxes, an array of those many boxes. And then you start selecting one at a time and start placing it in the boxes. Is this visible to you guys? Is this PDF visible?
And it's not clear, ma'am.
Not clear? Shall I zoom? Is it visible now?
Yes, ma'am.
Okay, see, first is you have to write it in descending order, and after you write it in descending order, next you'll have to take the maximum deadline, have an array of those many boxes, and then you're selecting the first job and you're trying to place the job. You also need to write to the side over here. Okay, in this particular place, you need to write what was the profit that you will be earning when you're selecting this particular job. That is missing over here, so you need to add that as well. So when you come to the second one, it will become 200 plus 125, that is the profit earned. You'll have to write over here. Okay, so this way you'll have to do for each and every step of your job scheduling, and finally you'll be writing what is the maximum profit earned. Okay, so please follow these steps. If you miss these steps, you basically tend to lose marks. Now, coming to the topic of Warshall's algorithm, this is the next topic that we'll be learning. I said I will be teaching you guys this because it's been a long time since I've taken class for you. One point. The other point is I need to basically rush up to finish portions for you as well, so that you understand each and every concept properly. Now, this is also a part of one of your lab program, Warshall's algorithm. So you need to understand it clearly. So when you're talking about Warshall's algorithm, the main concept that Warshall's algorithm uses is transitive closure. Transitive closure means transitive closure of a directed graph with n vertices. This is the definition of what a transitive closure is all about. So I'll just read the definition and then I'll explain it to you. Fine. So transitive closure of a directed graph with n vertices can be defined as a n by n Boolean matrix. It's called Boolean matrix because it contains only zeros and ones, in which the ith row and jth column is 1 if there exists a non-trivial directed path from ith vertex to jth vertex. Otherwise, that particular entry is 0. Now, if you see over here, this is the adjacency matrix for this particular graph. We have this directed graph which is 1, 2, 3, and 4 with how many edges? 4 edges. Yes, we have 4 vertices and 4 edges. So this is the adjacency matrix for this particular graph. Now, once you finish computing the Warshall's algorithm for this particular graph, you will find that there is a path from 2 to 3. So now you can go from 2 to 1 and 1 to 3. So we have a indirect path from 2 to 3. So you know, right, transitive closure property, A to B. If you have from A to B and from B to C, then you can tell you can go from A to C. So the same property we are going to use over here. So you can go from 2 to 1 and 1 to 3. That means we can directly go from 2 to 3. So this is these yellow arrows that you can see are the paths that are present between the vertices. Now if you take from 4 to 2 I can go, and 2 to 1 I can go. So that means 4 to 1 also I can reach. So if I can go from 4 to 2, then 2 to 3 if I can go, then 4 to 3 also I can reach. If you see over here 4 to 2 and 2 to 4, again I can go and come back to 4 again. So that way 4 will have a self loop, meaning 4 to 4 also is reachable. 2 to 2 is also reachable because of this loop that is present over here. So how do we solve this and come up with this particular uh, adjacency matrix with the transitive paths we are going to see? Okay, so basically warshall algorithm computes transitive closure of a relation. Uh, so let's just check. If you take const- Warshall's algorithm constructs transitive closure as the last matrix in the sequence of n by n. So you start taking R of 0, R of 1, R of 2 up to R of n. Wherein what we do it at each R we take the ith row and the jth column. Okay, you take ith row and the jth column. Meaning for R of 0 I would have taken the first row and first column. For R of 1 the second row and second column. For R of 2 third row and third column and so on. Okay, like that we will be selecting. Now this particular R of 0 here what they've taken is the basic adjacency matrix that you've got for this particular algorithm. When I'm choosing the first row and first column, I can basically find out that there's a transitive path from 2 to 3. Okay, so wherein I go from 2 to 1 and 1 to 3. So this particular place becomes 1. Okay, yeah, so this particular place becomes 1. Now the next thing, if I take the second row and second column, okay, you can find that there are three edges, three positions here which are becoming 1 which was initially 0. Okay, so how exactly this works we will see. This is just a diagrammatic figure that I've given. You can see you can go from 1 to 4. How do we go from 1 to 4? Sorry, 4 to 1. 4 to 1 we can go from 4 to 2 and 2 to 1. So 4 to 1 is possible. Then 4 to 3. 4 to 3 is also possible because you can go from 4 to 2 and 2 to 3. And then 4 to 4 is also possible because you can go from 4 to 2 and back to 4 again. So like this you can go on. So how exactly does this algorithm work? If you see, rule 1 is if the I element in row I and column j is 1, then basically in R of k minus 1, if it is 1, then it remains 1 in R of k. If it is not 1, if it is 0 in R of k minus 1, then it has to be changed to 1 in R of k if and only if element in row I and column k and the element in its column j and the row k are both ones. I'll just tell you what this means. Now here if you see, this is the initial matrix you have, right? Now we take the first row and first column. When you take the first row and first column, you find that there is a 1 over here. Yes? What is this position? 0 comma 1 or 1 comma 0? You can answer me, anyone. What is this position? 0 comma 1 or 1 comma 0?
1,0.
This is 1 comma 0, meaning you go from B to A, correct? And how about this particular position? Wherever there is a 1, we need to look at it. So how about this position? This is 0 comma 2, right? That means A to C. So this is from B to A and this is from A to C. So since I can go from B to A and from A to C, then that means I should be able to go from B to C. So this is the kth position. Okay, this is the kth position that we are talking about. So you can go from B to A and A to C, meaning I can go from B to C. So I need to make this particular position as 1. That is the intersection between the row where you have 1 and the column where you have 1. Okay, that particular place you need to make it as 1. You understood how this works? Yes, the intersection where you find 1 in the row and 1 in the column, that particular position becomes 1, indicating that there's a transitive path from this node to this node. Okay, so that way for this first row we don't have any other ones. Okay, and first column also we don't have any other ones. So this is what, so this is the only node that will become 1. Now, the next path, what we are doing is we are having first column and second row and second column. So when you take second row and second column, you find there's a 1 over here. Yes, there's a 1 over here. So since there's a 1 in this particular position, this is 0, 1, 2, 3. Yeah, 3 comma 1. This is 3 comma 1 and this is 1 comma 3. So 3 comma 1 and 1 comma 3, basically it will be 3, this particular position, sorry, 3 comma 1 and 1 comma 2. So it will be 3 comma 2. So this particular position 3 comma 2 becomes 1, because this is 1 and this is 1. Same way you find here, this is 1 and this is also 1. So this location also becomes 1. Go this side. You have this and this, you have 1. So this particular portion also becomes 1. That's why we have 3 different vertices values which are becoming 1 in the next column. Okay. Now this, we finished with the first row, first column, second row, second column. Now third row and third column. In this we find in the third row there are no ones. That means there is no path from C to node 3 to any other node. So there is no way anything else will become a transitive path. So next we go for the fourth row and fourth column. Again in fourth row and fourth column. Now this is the only thing that is 1 over here, and there's a 1 in these 3 positions. So if you see 1 and 1, this is already 1, so no need to change. 1 and 1, this is also 1, so no need to change. But here we find for this and this is a 0. But we find there's a 1 here and 1 here. So this particular location alone becomes 1. So this is the final transitive closure matrix that we get after we compute Warshall's algorithm. Any doubts? This is the concept tracing for Warshall algorithm. So no matter how many vertices you are given, those many rows and those many columns you will have, and those many times you have to do this job of selecting the row and column each time. Fine. And finally, whatever you're getting, that will be the transitive closure matrix for that particular algorithm. So code is very simple for this. Initially, we are taking the adjacency matrix as R of 0. Then for K is the intermediary nodes that we are choosing. Okay. Say for example, we went from here, if you see, first row, first column, second row, second column, third row, third column, fourth row, fourth column. So here basically each time which column and row we are selecting, that will be the value of K that we are talking about. Okay, so this K has to go for how many ever rows and columns we have, that many times. Now each time you take, we start checking from each row with each column. Okay, so that way you have I and J, row and column values. So what exactly I do is, I am telling that particular portion of R of ij, this particular portion of R of ij will be 1 if there is a value from this particular, if there's a 1 over here and there's a 1 over here. And the 1 here is I comma, sorry, this is column, so it will be j comma k comma j, and here this will be I comma k. Yes or no? This was what 1 comma 0 and this is 0 comma 2. Correct? 0 comma 2 and 1 comma 0, it will give you the value for 2 comma 1 comma 2. Okay, so when we are finding out for 1 comma 2, we will be taking 1 comma 0 and 1 comma. So what we are doing is we are checking for each and every vertex. We are not just directly checking where there is 1 and doing it. Instead we are checking for each and every value. So 0 comma 0 also I will check, 0 comma 1 also I will check, 0 comma 2 also I will check, 0 comma 3 also I will check. So each row value I am taking and I am checking with all the values in the column. So accordingly I will be trying to modify the values in this particular intersection between the values. Okay, so that way I will try to modify the values of all these remaining nodes in the matrix. So for k equals 1 to n, that is for the which row and which column. for I is for the row, J is for the column. Each and every value of that row and column I'm taking, and I'm checking if the value in the previous thing is 1 or not. If it is 1, I can leave it as it is. If it is 0, then I have to use this particular method to find out. I have to find out if there's a 1 in I comma k, and also there's a 1 in k comma j. If this is true, only then I'll be putting it in R of I comma j as 1. Otherwise, I'll be putting it as 0 as it is. Okay. So since we have 3 for loops over here, you have sigma of I equals k equals 1 to n, sigma of I equals 1 to n, sigma of j equals 1 to n, and there is only one line that is executed. So if you use your summation formula, you can find out that time efficiency becomes theta of n cube. Okay, so you can use summation formula and you can try to solve this particular problem.
Ma'am, for Dijkstra and Prince algorithm, should we like show the
Yes, my
illustration
dear,
after each
you have to
step,
do that
ma'am?
concept tracing and you have to show. If it is say
Okay,
for
ma'am.
1 or 2
Thank you.
marks directly you can do, but if not, you have to basically do that concept tracing and you have to show. And please remember for Digixtras, don't use any other tabular method other than whatever I've shown you today. Okay, use the 3 column method itself to solve it.
Okay, ma'am.
Any other
Thank
doubts?
you, ma'am.
Warshall's algorithm, if you want to implement it, is very simple. All you have to do is just put 3 for loops, check for a condition if it is 0 or not. If it is 0, then you have to check for whether there is 1 or not. If not, you don't have to do it. So luckily for you guys, they've removed it from your lab program. I mean, or I should say unlucky. Uh, so it is not there. You can, if you are interested, you can try writing the code for Warshall's algorithm. But when it comes to Floyd's, we will see. It follows the same procedure, so that time I can explain it to you. But the only difference between your Floyd's and your Warshall will be in Warshall you are trying to find the transitive closure path and you are trying to change your adjacency matrix. Okay, you are trying to change the adjacency matrix in Warshall's algorithm. Whereas in your Floyd's algorithm, you will be working on your cost adjacency matrix. So when we find the cost adjacency matrix and we use transitive closure, automatically we can find the shortest path for each and every node. That is one reason why your Floyd's is also called as all pair shortest path algorithm. Okay, so that we will see in the next class. So if you guys don't have any other doubts, really you guys are unlucky that they removed Warshall for you guys. So we will meet in the next class. So prepare well for your internals and please do well. I don't want to see people writing half and half answers and losing out on your marks. Fine. So follow all the methods that I have taught to you and please do follow the steps when you're writing. Don't just write for the sake of writing something and leaving it. Because if it is for a 10-mark question, you may, if you are just writing only the figure and coming up with a final answer, for the final answer, you will be given some marks. But for the steps, you will get the marks.